Assalamualaikum and hi everyone. In this video, we are going to present a group project assignment for CHM256 titled Basic Chromatography and Separation and Analysis of Food Dyes in Candy Shells using Paper Chromatography. This is our group members. What is chromatography in general? Chromatography is an analytical technique used to separate and isolate components in a chemical mixture. The separation process is based on the different rates at which substances move through two phases. First, a stationary phase which does not move. Second, a mobile phase which flows and carries the sample. Each component interacts differently with the two phases depending on its polarity and solubility. This technique allows for both qualitative analysis which identifying substances and quantitative analysis which measuring how much is present. Chromatography is classified into two main methods. First, planar chromatography, which includes paper chromatography and thin layer chromatography. Second, column chromatography, which includes gas chromatography and supercritical fluid chromatography. Next is food chromatography. Food chromatography is a specialized application of chromatographic techniques used in the food industry to analyze the chemical composition of food products. It is mainly used to separate and identify different compounds such as artificial, additives, preservatives, and dyes. This technique plays a crucial role in ensuring product safety and maintaining quality control. It is also support regulatory compliance by helping detect unwanted or unauthorized substances, which is essential for meeting local and international food safety standards. Food chromatography is commonly applied in processed food and beverage testing to detect the presence of unapproved dyes, contaminants, or undeclared additives.
Now, I will be explaining the basic theory behind chromatography. Chromatography works based on two phases, stationary phase and mobile phase. The stationary phase is the static part of the chromatography setup. It is usually dark or solid or sometimes coated with a liquid stationary phase that remains fixed in place, either in a column or on a flat surface which is planar. This phase functions by absorbing the components that are being separated. When a solvent and analyte pass through it, they interact differently with the stationary phase, causing them to separate. You can see an example in the image here, showing a pepper with a separated color spot. Next is the mobile phase. Mobile phase is a moving part. It can be gas, liquid, or even a supercritical fluid. Its job is to carry the analyzed mixture through the stationary phase. As it travels, the different substances in the mixture move at a different speed, depending on their interaction with the stationary phase. This is what causes them to separate. There are two main types of chromatography methods, which is planar chromatography and column chromatography. Let's go into a bit detail on each. In planar chromatography, the stationary phase is supported on a flat surface, for example, which is paper chromatography, and TLC chromatography, which is thin layer chromatography. This method is especially useful for separating polar and non-polar compounds, and also for identifying color substances like pigment. Meanwhile, in column chromatography, the mixture is separated in a vertical tube filled with stationary phase. The mobile phase is processed through the tube, either by pressure or gravity. These methods allow better control and higher efficiency and is used for separation, identification, and purity checking. Now, let's look deeper into two important methods of planar chromatography. Paper chromatography uses a special paper made of cellulose fiber, which contains trapped water molecules. The paper acts as a stationary phase. It helps separate the sample mixture into individual components. As the paper was hung and dipped into a solvent, the solvent travels up the paper. The mixture components move at a different rate and separated into spot. TLC chromatography. TLC's chromatography is stand for a thin layer chromatography, and it uses a glass plate coated with silica gel or aluminium oxide. The silica gel layer acts as the stationary phase. To run the chromatogram, the bottom of the plate is dipped into the switchable solvent. The solvent then moves upward by capillary action, separating by the substance. TLC is often used for more advanced or sensitive separation. There are two main mechanisms of separation. First is partition chromatography. This is a type of involved distribution of components by dissolving. It happens between two immiscible liquids, which is liquid mobile phase and liquid stationary phase. The solid equilibrates or balances itself between both liquids. Thus, paper chromatography is a good example of this type. Second is absorption chromatography. Here, separation occurs by absorption onto the surface of the solid stationary phase. The mobile phase carries the mixture through this surface. The different components in the mixture stick the surface with different strength. This difference causes them to move at different speed and eventually separate. Therefore, TLC is a classic example of absorption chromatography. Now, let's move on two concepts used to analyze chromatography results. Retention time is the time required for a sample to travel from the injection point through a column and finally to the detector. It tells us how long a component takes to move through chromatography system. Each substance has its own retention time, which can help us identify it. Next is the retention factor. This is commonly used in paper and TLC chromatography. RF is a ratio of how far the substance moves compared how far the solvent moves. It has helped us compare how strongly different substances interact with the stationary phase. RF value range is between 0 and 1. If it is equal to 0, the substance do not move at all, meaning it is highly attracted to the stationary phase. Meanwhile, if it is equal to 1, the substance moves completely with the solvent front, meaning no attraction to the solvent phase. To calculate RF, this is a simple formula is used, which is RF is equal to distance traveled by the component, which is A, divided by distance traveled by the solvent, which is B. This gives us a value between 0 and 1. Looking at the diagram, A is a distance part, which is component travel, while B is a distance the solvent travel.
Okay everyone, it's time to us for dive into some candy science. Our experiment today is called Separation and Analysis of Dyes in Candy Shells using Paper Chromatography. But don't worry, it's way more fun than it sounds. You can see those bright candy colors are not always what they seem. There are sneaky little blends of different dyes, but lucky for us, chromatography is like a superhero. It swoops in, split them apart, and shows us what's really going on behind the rainbow.
I'm gonna start with the introduction of the experiment. Most candies are coated in synthetic dyes used by the food industry to make products visually appealing. These dyes aren't usually single compounds, they are mixtures, which makes them perfect for analysis using paper chromatography. Paper chromatography helps separate these mixtures by relying on each dye solubility and its interaction with the paper and solvent. As a result, different dyes travel at different rates and produce beautiful, densely colored bands. In our experiment, we are focusing on candies with coatings in 5 different colors: blue, green, yellow, red, and brown. These colors often come from common food dyes such as Allura red, brilliant blue, tartarzine, sunset yellow, and fast green. By applying chromatography, we will identify which dyes are present in each candy and gain a better understanding of how these colorful traits are composed.
Next, the objective of this experiment is to separate and visualize the individual dyes component in candy coatings using paper chromatography. Second is to determine the retention factor values of different colored dyes present in various candies using paper chromatography in order to identify and compare their pigment composition. So in this experiment, the apparatus that we use is filter paper as the stationary phase for the chromatography, beakers and stirring rod to mix the solvent and hold the samples, toothpick to transfer the candy dye onto the paper, and ruler, also pencil, to mark the baseline and measure dye migration. As the materials include the colored candy samples, which provide the food dyes that we are analyzing, table salt acting as the solute, and distilled water, which serve as solvent to create the saltwater solution that act as our mobile phase. Now, let's go through the procedure for this chromatography activities step by step. So step 1, prepare your chromatography strip. Cut a piece of filter paper about 2 to 3 cm wide and long enough to hang into a cup without touching the bottom. Using a pencil, draw a horizontal baseline about 2 cm from the bottom and label the candy color above the line. So step 2, we're going to extract the candy dye. Place one color candy on the clean surface or small piece of foil. Add a few drops of water and let it sit until the dye dissolves. Step 3, prepare the saltwater solution. Put about half a teaspoon of salt into 200 ml of water and stir until it dissolves completely. Then put just enough of this salt water into the bottom of the beaker, that only enough to touch the very bottom of the chromatography strip when it's placed inside. Step 4, apply the dye to the paper. Use a toothpick or a cotton swab to transfer a small drop of the colored candy solution onto the backside of the chromatography paper. Let the spot dry and, if needed, repeat the process to build up more concentrated dye spot. If you are testing more than one color on the same strip, be sure to space each one out evenly. So step 5, set up the chromatography. Take the prepared strip and tape it to a stick or pencil. Gently lower it into the beaker so that the bottom edge of the strip just touch the surface of the salt water, and also make sure that the dye spot do not touch the liquid directly. Leave the setup undisturbed to let the solvent move upward through the paper, carrying dye with it. Step 6, observe and record. When the solvent front is close to the top of the strip, carefully remove the paper and set it aside to dry. And once it dry, observe the dye band and count the number of distinct colors. Record your observation for each candy sample and calculate their RF value to analyze the dye component.
This is an example from a paper chromatography experiment. The color pattern you see here is called chromatograph. The baseline is where the candy start dyeing, and the top line is where the solvent stop moving, called solvent front. Okay, so this is the table data of the result. So we included the dye colors that have been separated and the RF value. For information, RF value is distance that dye that have been traveled divided by distance that solvent have been traveled. So The first one is red candy color. Total distance solvent that have been traveled is 8.2 cm. The colors that have been separated is pink and red, and distance each dye traveled in cm is 2.5 and 4.1, and the RF value for each dye is 0.3 and 0.5. Second one, yellow. Total distance solvent traveled in cm is 7.9. Dye color separated is still yellow. Distance each dye traveled is 6.2 cm, and the RF value is 0.78. Third one is green. Total distance solvent that have been traveled is 8.0 cm. So green has been separated into two colors, which is green and blue. So distance each dye traveled in cm is 3.5 and 6. So the RF value is 0.44 and 0.75 cm. Brown. So total distance solvent traveled in cm is 8.3. So the colors that have been separated are orange and blue. Distance each dye traveled in cm is 5.9 and 3.7. So the RF value is 0.71 and 0.45. Last one is blue. Total distance solvent traveled is 7.8 cm. So the dye have been separated into blue and light blue. So distance each dye traveled in cm is 3.1 and 5.8. The RF value for each dye is 0.4 and 0.74. Thank you. For discussion, this experiment shows that paper chromatography is an effective method to separate and identify different dyes in candy coatings. Each color is separated into individual pigments, revealing that many candies are made from a mixture of dyes. The results are also shown that different dyes have different RF values, depending on how well they dissolve in the solvent and how strongly they stick to the paper. This technique helps us to understand the chemical makeup of food colorings and how different components behave during separation.
In conclusion, this experiment helps us to understand that the colors found in candy are mixtures of several other color components. The pigments in the candies was identified and compared as a result to the computed RF values for each dye component. Therefore, this experiment shows that candies often contain more than one type of dye, even if they look like a single color. This method is very useful in the food industry. It helps companies make sure they are using the correct dyes, follow safety rules, and give honest information on labels. Chromatography is like a tool that helps keep our food colorful and safe.
This is our reference. That's all from us. Thank you.